The angle of elevation of the top of the CN tower from the point of view of boat A is 18 degrees, while the angle of elevation of the top of the tower from the point of view of boat B is 12 degrees. If the height of CN tower is 553 meters and the boats and the base of the tower lie on a straight line, compute the distance between the boats. The key to solving questions of this kind is a proper illustration. We have the CN tower, which is 553 meters, and we have the sea level, and then we have two boats, which at the moment I'm assuming to be both on one side of the tower. Boat A, which is closer to the tower and therefore has a larger angle of elevation for the top of the tower, which would be 18 degrees, and boat B, which is farther from the base of the tower and records 12 degrees for the angle of elevation of the top of the tower. The question is asking for the distance between A and B, which I show by X. Let's call the base of the tower O and the top of the tower T. We are assuming that the tower is perpendicular to the sea level. Therefore, the angle TOA is 90 degrees. Now, in the right angle triangle OTA, I can write OT divided by OA is equal to tangent of 18 degrees. Since OT is 553 meters, I can solve for that. Divided by OA, that is tangent of 18 degrees. This equation involves one unknown, which is OA, and I can solve it to find OA. I would have, by cross multiplication, 553 times 1 equal to tangent of 18 degrees times OA. And if I divide both sides by tangent of 18 degrees, I would have OA is equal to 553 divided by tangent of 18 degrees. And I will summarize this as OA to be 553 divided by tangent of 18 degrees. And I keep OA as it is. I do not use my calculator to turn this result into a decimal number. In the same way, I can calculate OB. If we look at the triangle TOB, which is a right angle triangle, we can write TO divided by OB is equal to tangent of 12 degrees. But we know that TO is 553 meters divided by OB, that is tangent of 12 degrees. This equation has one unknown which we can solve for. By cross multiplication, we get 553 times 1 is equal to tangent of 12 degrees times OB. And if we divide both sides of this equation by tangent of 12 degrees, we find that OB is equal to 553 divided by tangent of 12 degrees. I just summarize the result as OB is equal to 553 divided by tangent of 12 degrees. The reason we calculated OA and OB can be seen from the illustration. We note that if we subtract OA from OB, we are left with the distance that we are looking for, which is x. Therefore, we can write x is equal to OB minus OA, which is 553 divided by tangent of 12 degrees minus 553 divided by tangent of 18 degrees. If we use our calculators, we'll see that this becomes equal to 899.7 is approximately equals to 899.7 meters, and we need to consider two significant digits if we wanted to consider significant digits, and this, after rounding, becomes 900 meters with two significant digits. This would be the distance between the boats if we assume both of the boats are on the same side of the tower. Another possibility would have been to assume that the boats are on different sides of the tower. Let's say both one of the boats, let's call it both A, is on the, as the illustration shows, on the right hand side, let's say 18 degrees, and the other one on the left hand side with the angle of elevation of 12 degrees. Okay, there would be a boat here. Now, this is not possible for CN Tower because in case of CN Tower, water exists only on one side of the tower. But if water existed on both sides of the tower, then we could also consider this possibility. In this case, we can show that actually the distance between the boats, again I showed them by A and B, would be 553 divided by tangent of 12 degrees plus 553 divided by tangent of 18 degrees. And if we use our calculator, that adds up to 4,303.6 meters with two significant digits, which after rounding becomes 4,300 meters.